All right, so if I have a group of people, let's just call it club, I'll call this one Club Z, for whatever arbitrary reason there. But we've got 4 people in this club. All right, number 1, how many ways could they elect a president and secretary? How many ways could they elect the president and secretary? All right, now, a couple of points on this one. First of all right, so we've got Rachel, president, and then Steve is secretary. So the first point here is on electing officers. It doesn't say we can't repeat, does it? But we're going to say if we're going to elect officers, there needs to be 2 different people. All right, so no repetitions when we're electing officers. Okay, that's going to be implied. No repetitions. All right, so in other words, we can't have Rachel as president and Rachel as secretary. So we won't do the same person twice. All right, so Rachel, Steve, then we could do Rachel, Tina. That would be president and then secretary, and then Rachel, Vicky, president and secretary. So that would be all the ones with Rachel as president. Then I could turn it around to Steve as the president. And Steve, Rachel. Would that be different than Rachel, Steve? Yeah, because Steve is president, Rachel is secretary. So when we elect officers, the order is important too, okay? Order is important, meaning changing the order changes the outcome. That's what that means. So I could have Steve, Tina, and then Steve, Vicky. Then I could go Tina is president, so I could have Tina, Rachel, Tina, Steve, and then Tina, Vicky. And then last but not least, I could have Vicky as president, so Vicky, Rachel, Vicky, Steve, and Vicky, Tina. And I believe that would be all of them, wouldn't it? 12 of those as well? 12 ways there too. Okay? Now, sometimes they'll, sometimes they'll say, well, how many ways could this happen? Or they may make some other restrictions, I guess you might say. How many ways could they elect a president, a vice president, and secretary if Steve and Tina cannot serve together? For whatever reason, they don't get along. But, yeah, so sometimes they may make an extra little thing like that. So in this case, we've got 3 officers, president, vice president, and a secretary. Okay, so if I start with Rachel, here's the president. And then I can have Steve again as vice president. But Steve and Tina cannot serve together, so I'm going to leave off Tina here and go to Vicky. So this is going to limit my options here, even though I'm electing 3 officers. Are there any others with Rachel as president? Yeah, I could do Rachel and then Tina with, now I couldn't do Steve because Tina and Steve don't serve together. So I go Rachel, Tina, Vicky. And then I could also have Rachel as, and that'd be the only one with Tina as the vice president, Rachel president. But I could also have Rachel and then Vicky as vice president. So that'd be Rachel, Vicky, Steve, and Rachel, Tina. So again, just kind of some type of order system to kind of go through there. So start with Rachel president and then cycle through the other ones. All right, so let's go with Steve president. What can we do there? Steve, I could have Rachel as vice president, but I couldn't have Tina, so I've got to have Vicki there, right? Could have Steve as vice president, and couldn't have Tina as vice president, so I could have Vicki as vice president. Be the only other way to go there. Of course, that'd have to be Rachel and then as secretary. I believe that's it for Steve president. And then just do the rest of it. So Tina, I think it's going to be very much like that. Tina, Rachel, and then Vicki, because we're going to have Steve in those. And then Tina, Vicki, Rachel. And then last but not least, Vicki. So we're going to have Vicki and then Rachel with Steve, and then Vicki, Rachel, Tina. Then we could have Vicki with Steve. So then it would have to be Rachel. We have Vicki with Tina, and then Rachel. I believe that's it. Think of any others? I believe that's it. So again, we got 12. Now, any questions on that one? Everybody believe that? Is that okay with everybody? Now, with this same club though, let's think about a different way of selecting people. And that is, we're going to do this in the context of a committee. How many committees of 2 could they form? Well, this is a different thing, a different deal. We still obviously can't repeat, all right? So there's still, for committees, there's still no repetitions. You still can't repeat because you have to have 2 people. So Rachel is not 2 people. That's fairly obvious. All right, so we got Rachel, Steve, and then Rachel, Tina, and Rachel, Vicki. Here's, however, the difference between the officers and the committees. If I think about Steve, Rachel, is that a different committee than Rachel, Steve? It is. That's a different committee. It's the same 2 people, isn't it? That's the same committee. Huh?
Who's in the lead and who's not?
Well, there's no, we're not electing a chairperson or anything like that. I know what you're saying, but no, we're just talking about the committees. Then we'll talk about maybe the chairperson. Yeah, there's no specific order here, no rank in the committee. So Steve, Rachel, that's the same as Rachel, Steve. In committees, Steve, Rachel is the same as Rachel, Steve committee. Because it's the same 2 people, all right? So when you do committees, the order doesn't matter. In other words, changing the order doesn't change the committee. You've got to change at least one of the people to get a different committee, okay? The order doesn't matter. So I'm not going to list Steve, Rachel here. It's the same one. So I'd have to do Steve with somebody different that I don't have listed. Steve, Tina, and then Steve, Vicki. With me there? Everything else I would try. Steve, like I said, Steve, Rachel's the same. So we're going to have fewer here, aren't we? Then we could go, let's see, Tina. Is there anybody, Tina? I don't have a committee listed with Tina. Steve, Tina, Vicki. There's only 6. Only 6 of those. Any others, because of the order not mattering, would be a same committee as something I've already got listed. I believe so. All right, so let's go ahead and do the committees of 3 here, just to get a little more practice on that. So committees of 3, how many of those are there? So we have Rachel, Steve, Tina. We could have Rachel, Steve, Vicki. We could have Rachel, Tina, Vicky. I believe would be the ones there. With Rachel, anything else we could do with Rachel would be repeating, because the order doesn't matter. And I could do, let's just do it here, because I believe that's it. Steve, Tina, Vicky. There's only 4. Anything else, because the order not mattering, anything else would be a repetition of it. So there's only 4. All right? Good with that? Now, let's do one more type here, and it's a little different. Well, let me do this. All right. So, how many? Back to the digit number ones here. How many 3-digit numbers have the sum of their digits equal to 5? How many 3-digit numbers have the sum of their digits equal to 5? So this is going back to that numbers problem a little bit. Now, in this particular case, it doesn't say there's a limitation on the digits, right? 3-digit numbers, and so what are the possibilities? Well, I mean, there is a limitation because we can only do a sum of 5, but when I talk about digits of a 3-digit number, the possibilities are 0 through 9, possibly. Now, because it's just a sum of 5, I'm not going to be able to do 6 or 7s, right? But I could possibly have 0 through 9. But again, with the sum of their digits equal to 5, I am limited. So what would be one possibility? 3-digit number, sum of the digits equal to 5.
0, 2, 3.
Now, again, if I want it to be 3-digit numbers, the first digit can't be 0. So how about 203?
203.
203, okay. Thank you. Now, what I like to do when I come up with digits like this, so adding those up, you got 5, right? 2 plus 0 plus 3 is 5. Now, with those 3 same digits, I can make some other variations, right? Like 230, 320, 302. I did them in a different random order there, but you see what I'm saying? If you've got 3 digits that add up to 5, then you can rearrange those, and those are all 4 different numbers, right? They're 3-digit numbers. All right.
Repetition.
Repetitions, yeah. On 3-digit numbers, 4-digit numbers, if it doesn't say no repetitions, you can. So, what are we going to think?
221.
221. Okay, so 221. Other possibilities with those 3? 212, 122. How about 410? 410, 401, 104, 140. 500. Of course, 500, you can't rearrange those because any other rearrangement, we'd have to start with a 0, right? So to be a 3-digit number, you can't start with a 0. Anything else?
113.
113. Thank you. So 131 with those same, and 311. Any others?
123.
123 gives us 6, doesn't it?
No. Oh.
1
right.
plus 2 plus 3 gives us 6. So I'm gonna think that's it. I don't have these listed, but I think that's it. I think anything else would be something we've already got, or be a different sum. So how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, I believe that's right. 15 of them altogether. So there's variations on these types of problems, but really this is one where listing is about the best way to do it. systematic listing. But I got one more type of problem. Any other questions on that? You may have seen some of these before. You may have seen this one in particular before. We got a triangle, and then I've got some other triangles inside of it. Something like that. So, how many triangles? And the key to this one is of any size. Are there in this particular figure? Okay, so here's, we're trying to look at systems. So here's a system. To keep up with what I've done here, let's number off these parts. 1, 2, 3, 4, and 5. So obviously, now one thing I will caution you on is be sure that if you number them off like this, if you say there's 5 of those, be sure they are triangles. Sometimes they'll sneak in a 4-sided or more sided than 3. So be sure you are counting the triangles. So there's 5 of the triangles there.
You want
Small
the triangle itself?
Then you got the big triangle. Yeah, the big triangle, which is 1 through all 5 put together. There's some others though. Isn't there? Isn't 2, 3 a triangle of a different size?
Yeah, 4, 5.
4, 5. 3, 5.
2, 4.
2, 4. So you got those two-parters, right? Any others? Now, that's a good example too. 1, 3, not a triangle. 1, 3 has 4 sides.
1, 3, 5.
1, 3, 5. All right, so let's go through. We could put 3 of them together. 1, 3, 2. Any others there? I don't think so. I think any of the other three put together would give us not a triangle. So, and putting 4 together, I don't think that works. So I think with our system here, we've run through them, haven't we? We've got the one each piece separate. Then we got the big triangle with all 5. Then you got the 2 sides and the ones with sides of 3 put together. I think that's it. So, if you're just saying, well, here's this one, it's kind of hard to keep up. So this again just kind of will give you a little system to keep up with. There's 12, I think, in there. So there's 12 there. So anyway, that's another type of problem I might come across on these.